The last thing I'm going to mention in this lesson is how exactly you're going to be making a decision. How are you going to be deciding whether you're rejecting the null hypothesis or failing to reject the null hypothesis? First, I want to mention what a test statistic is. The test statistic is a value that measures how many standard deviations the observed sample value is from the claimed population parameter. Let me give you an example. Let's say we're talking about a hypothesis test for a proportion, and let's say that the claimed population parameter is p equal to 0.60. And let's say that the observed sample value is p hat equal to 0.4. Your test statistic in this case would be the z-score corresponding to p hat equal to 0.4. So again, this is the p hat distribution. The test statistic would be the z-score for p hat equal to 0.4. That test statistic would tell you how many standard deviations p hat is away from p. Now, it could also be the case that you're doing a hypothesis test for a mean, and let's just say that you don't have the population standard deviation. In that case, we're going to have to use the t distribution. And let's say that the center of this distribution is mu, the claimed population parameter, is mu equal to 70. And let's say that the observed sample value is something like x bar equal to 89. Then in this case, your test statistic is the t-score for x bar equal to 89. That t-score is going to tell you how many standard deviations x bar is away from mu. If you have a really large value, a really large positive value or a really large negative value for the test statistic, that means you're really far away from the center. That means that it's really unusual to see the observed sample value that you got. Now, in this class, we're not going to be using the test statistic. We're going to use the p-value. I wanted to mention what the test statistic is because there's some studies that mention the test statistic. So again, if you see a really large positive or negative value for the test statistic, that means that the observed sample value is really far from the center. That means that it's really unusual. Let's go ahead and talk about the p-value. The p-value is going to be the probability that the test statistic will take on more extreme values than the observed test statistic, given that the null hypothesis is true. So now we're talking about the probability of observing such a test statistic. You can also think of the problem having the observed sample value, the value that you got from the sample. For example, the p-value could be the area to the left of p hat equal to 0.4 here in our first example. On our second example, the p-value could be the area here to the right of x bar equal to 89. However, the p-value could also be the area on both tails, and we're going to see that in another lesson. Here, just note that the p-value is going to depend on the alternative hypothesis. If the alternative hypothesis has a less than sign, then your p-value is going to be the area on the left tail. If the alternative hypothesis has a greater than sign, then the p-value is going to be the area on the right tail. If the alternative hypothesis has a not equal to sign, then the p-value is going to be the area on both tails. For now, just note that the p-value is the probability of getting the observed sample value or something more extreme. It's really important for us to have the p-value because the p-value is going to help us make a decision. If the p-value that you found is less than alpha, then you're going to be rejecting the null hypothesis. If the p-value is greater than or equal to alpha, then you're going to fail to reject the null hypothesis. Now, in our next lesson, I have a summary of how you're going to be carrying out a hypothesis test. And the last step is going to be making a decision. I'm going to remind you that if the p-value is less than alpha, we reject the null hypothesis. If the p-value is greater or equal to alpha, then we fail to reject the null hypothesis.